Determine all solutions for the following equation over the specified domain. For this equation we have 2 cos squared of x minus root 3 cos x equals 0. We're going to solve it over x is an element of 0 to 2 pi. If we have a look at our equation, we can see that it's got a bit of a quadratic feel to it. We've got cos squared x here, and then just cos x here. So because of the structure of this equation, we're going to solve it a little bit like a quadratic. So in the past, when we've solved a quadratic, we would have factorised and used the null factor law. So that's the same approach we're going to take now. So the first thing we're going to do is take cos x out as the highest common factor, and that will leave 2 cos x minus root 3 inside the brackets is equal to 0. And now we can use the null factor law to solve this. So according to the null factor law, this could equal 0, or this factor could equal 0, or of course they could both equal 0. So what we now have is two separate things to solve. So we're going to first solve cos x is equal to 0. So cos x is equal to 0 when we're in this position on the unit circle after pi on 2 radians, or when we're at this position on the unit circle, which is 3 pi on 2 radians. And we know that cos x is equal to 0 in those positions because cos x is read off the x-axis, and the x value of those 2 points are both 0. So that means that the solutions to this over 0 to 2 pi are x is equal to pi on 2, or x is equal to 3 pi on 2. Next up, we need to solve the equation that says 2 cos of x minus root 3 could equal 0. And if we rearrange that, what we're actually asked to solve is cos x is equal to positive root 3 on 2. And that's one of the exact values that we need to know for sine and cos. So if we want cos x to equal root 3 on 2, we're looking for our reference angle to be pi on 6. So this value here is cos of pi on 6 is equal to root 3 on 2. So that gives x equaling pi on 6 as another solution to this equation. And the other solution that is within the domain is x is equal to 2 pi minus pi on 6 because of the symmetry of the unit circle. And that symmetry is suggesting that the other solution is in the fourth quadrant, and that there is 2 pi minus pi on 6 around. So if we just go and evaluate that, that value is 11 pi on 6. Therefore, we have 4 solutions to this equation, x being pi on 6, pi on 2, 3 pi on 2, and 11 pi on 6.